Hello class, welcome to Unit 3 Video 4. Today you're going to learn about linear programming. Your learning target is that you can create and analyze a linear programming model to solve real-world problems. So in order to do linear programming, we kind of break it down into a nice 7-step process. Sounds like a lot, but the good news is a few of them you can take care of at the same time. But your first step is always to define the variables. So today you're going to be looking at word problems, and I need to know what is x and what is y. So you need to write down what they are representing. Your second step is that you're going to write a system of inequalities. The third step will be graphing those inequalities. The fourth step is going to find the coordinates of the vertices of the feasible region. Then step 5, you're going to write a linear function to be maximized or minimized. Okay, so that's what makes linear programming, or that is a big part of linear programming. They're real life problems, and they're trying to figure out, okay, if I want to minimize the amount of material I use, or if I want to maximize the amount of money I make. That's what the goal is with linear programming, to solve those real life problems and to tell a company, you should do this to make the most money, or you should do this to cut cost. So that's where linear programming comes in handy. Step 6 is to substitute the coordinates of the vertices into the function, okay? So essentially step 4, 5, and 6, I kind of make it into one step. We'll do it individually, and I'll show you how they kind of become one step altogether. And then step 7, you want to pick the greatest or least result to answer the problem. Okay, so for instance, if we're trying to maximize, you're going to want the greatest answer, and if we're trying to minimize, you want the least answer. Okay. So those are our 7 steps. Let's go ahead and look at an example. Okay. As a receptionist for a veterinarian, one of Dolores's tasks is to schedule appointments. She allots 20 minutes for a routine office visit. So I'm going to underline 20 minutes. Sounds important for an office visit. And 40 minutes for a surgery. The veterinarian cannot do more than 6 surgeries per day. Okay. The office has 7 hours available for appointments. And if an office visit costs $55 and most surgeries cost $125, how can she maximize the income for the day? Okay, so there is a lot of things going on, okay, but let's just break it down into our steps and go from there. Step 1, define the variables. Okay, so it's asking how she can maximize the income for the day. So I would say to myself, well, how is she earning income? It's through doing office visits and surgeries. So I'm just going to let x equal number of office visits, and then y will equal number of surgeries. Now we're going to go ahead and write a system of inequalities. Okay, so our first one I see is I have 20 minutes, 40 minutes, and then do I have another time? I do, 7 hours. Okay, so we got to be a little cautious. We got minutes, minutes, and hours. So since I already have 2 sets of minutes, let's maybe convert our hours into minutes. So how do I take 7 hours and convert it into minutes? I'm going to do a little 7 hours up here over 1. This is all the way back to Unit 1. And what's our conversion factor? We're trying to go to minutes. I know 1 hour is 60 minutes. This is multiplying. And our labels of hours cancel. So I take 7 times 60, which is 420 minutes. Okay. So instead of using 7 hours, we're going to use minutes. Okay, so 420 minutes. So let's put those labels together. So when you're writing your equations, it's probably the hardest part, but make sure you find a label and put those labels all together. Okay, so it's 20 minutes for an office visit. So I would have 20x plus, because my x is office visits, 40 for surgery. So 40 minutes for a surgery, which is y. And the office has 7 hours available for appointments. So should this be bigger than the 7 hours, which is 420 minutes, or should it be smaller than that? Okay, they can only be there for 7, so it has to be less than or equal to 420 minutes. That's my first inequality. Okay, I can always say I've used those numbers, now I'm not going to use them again. Okay. Then it says the veterinarian cannot do more than 6 surgeries per day. So that's another constraint. Okay, cannot do more than 6 surgeries. Well, surgeries is y, so I'm going to write down y. And so should this be greater than 6 or smaller than 6? Y needs to be smaller than or equal to 6. Okay. Then there should be two more equations that we're going to write. Okay, they seem silly, but it's important that you write them down. You write x, and you write has to be greater than or equal to 0, and we're also going to do the same thing with y. The reason we say they have to be greater than or equal to 0. Can you perform negative office visits? No. Can you perform negative surgeries? No. So then we put those two on there. Here are my two systems of my equation. Okay. Some of you would be like, well, what about the money? Okay. I would maybe write an equation for money if I had a total amount of money, but we are trying to maximize income, so we're actually going to use the money amounts later. Then we're moving to step 3. We need to graph them. One thing we could do is you could put them into slope-intercept form and graph it, but when the numbers get so large, it's a bit harder to graph those. So what I recommend for system of equations is to find your intercepts. So find your intercepts. Find. So let's look at our first equation. It is 20x plus 40y, and I'm just going to let it equal 420 to find the intercepts. Okay. Then I find my x-intercept. This is a review from Unit 2. We let y equal 0. Okay, so I'm going to plug in 0 for y. So I have 20x plus 40 times 0 equals 420. 40 times 0 is 0. So I'm going to ignore that. So I really have 20x equals 420. So I would divide by 20, divide by 20. So x is equal to, let's see, 21? Yeah, 21. Then I'm going to find my y-intercept. The way we do that is we let x equal 0. So I go to my equation, I plug in 0 for x. 20 times 0, we all know is 0, but 40y equals 420. This is 0. Divide both sides by 40, and 420 divided by 40 gives us 10.5. Okay. So that gives me another point. Okay, so my x-intercept, this point would be 21, 0. And this one would be x was 0, so 0, 10.5. Now that I have my intercepts, I'm going to go ahead and graph them. So I have 0, 10.5, which is right here, and then 21, 0. So 5, 10, 15, 20, 21. And then we connect them. Hopefully, I would highly recommend getting a ruler. If you're in my classroom right now, I have a ruler. Just come and ask me for one. Connect them. And then we have to remember with inequalities, we need to shade. Okay? So this one, I might check the point 0, 0, like we did in lesson 3.3. Plug in 0 here and 0 here. That makes this whole side 0. Is 0 less than or equal to 420? That is a true statement, and so I want to shade towards 0, 0. So I'm going to shade this way. Okay. There is that first line graphed. Then I would move on to my y is less than or equal to 6. Okay, those are pretty nice. When it's a y equals equation, they're always horizontal. The other thing I would do is I would say, well, where is y always 6? This is my x-axis, and this is my y-axis. So x is always 6. Here's 1. I think this is 6 right here. This is 6. So y is always 6 when I go up and down or left to right. Well, if you're not sure, start picking points. This point right here would be 0, 1. So my y value is 1. So that's actually wrong. But if I go like maybe here, this would be 5, 6. So my y is still 6. So it is a horizontal line. Whoops, mine is not very straight. Going across here. Okay, then we need to shade again. It says y is less than 6. So this would be up, bigger than 6, or we could shade down, less than. So there is this line graphed with the red shading marks. Now my x and y equations, basically what they do is if I were to graph them, x is greater than or equal to 0. X is always 0, up and down. So I would maybe draw my line. Hopefully I'm a little straighter here. And I would be shading to the right. And then I would do my y equation. And I would be shading upward. These two equations create it so we have a feasible region. If I did not graph those two, it would be wide open and I would just shade everywhere, even my negative answers. But we don't want negative answers, we only want positive answers. Now that I have done that, I would see that my feasible region would be where everything is shaded, so right here. Okay, so we have our feasible region, and that is step 3. And before we move on, I should actually say it's really, really important that we label everything. And I should have started probably with that. But X is number of office visits, so I have number of office visits. That's my X-axis. And my Y-axis, okay, hopefully I have a little more room. Actually, it's probably really crowded for you too. But this is number of surgeries. So make sure you are labeling those, making it nice and clear. Then step 4, you can easily see that on your sheet. I'm going to write it on the next page, but it says find the coordinates of the feasible region. So I have this point. So feasible region, we got, trying to find a good color that'll work for us here. Okay, this point right here, this point, this point, and this point. This point, and this one, okay? Those are pretty easy to see. So let's go ahead and write those down for step 4. We got 0, 0, then we have 0, 6, and then we have 21, 0. So we're going to write those down for step 4. 0, 0. 0, 6, and then the other one was 21, 0. Now, the other coordinate would be this one. Maybe you graphed and your ruler was super nice and it meets at a nice point, okay? It won't always be so nice. So what you're doing is you're finding where these two lines intersect. Well, this line, the equation is 20x plus 40y equals 420. We're going to solve it as an equals. And this is y equals 6. Then what we need to do is a system of equations. Back to the first half of Unit 3. We need to go ahead, and I can use substitution. I'm going to take this and plug it in for y. So I now have 20x plus 40 times 6 equals 420. Okay. 40 times 6 is 240. If I subtract 240 from both sides, 20x equals 180. And then I would divide both sides by 20. So x is equal to 9. So you can maybe see that it does look like it's 9, 6, but it might not always work out nicely. And so if it doesn't, you need to do a system of 2 equations. So this is where x is 9 and y is 6. So this is 9, 6. So we're going to go ahead and put that down. So our next one is 9, 6. Those are my 4 points of my feasible region. Then I move on to step 5. It says write a function to be maximized or minimized. Well, let's just take note. The equation is asking us to maximize. And what are we maximizing? Income. So we are maximizing income. And when I think about income, I think about money. Okay, so we got to maximize money. So what I do is I would write down how much an office visit costs. So it would be 55, and our office visit was variable x. So 55x plus 125y. That is step 5. Then step 6 is to substitute the coordinates from our step 4 into this equation. So if you want to skip 4 and 5 and just put all your answers for 6, that's totally okay. So the way I like to set it up is I like to make a nice little table. And I put x comma y because I'm going to write down ordered pairs. And then I write my equation. It's 55x plus 125y. My points. I got 0, 0. I have 0, 6, 21, 0, and 9, 6. Okay. Then you plug them in. This is your x values. this is your y. So it is 55 times 0 plus 125 times 0, which gives me a total answer of 0. Then I move on, I have 55 times 0 plus 125 times 6. Type it into your calculator, and you should get out 750. Then I move on, I have 55 times 21 plus 125 times 0 equals, once again, typing in your calculator, $1,155. And then our last point we got to plug in is 55 times 9 plus 125 times 6. And when I do that, I get 1,245. Okay, so there is all my options. Then step 7 says select the greatest or least result. We want maximum, so we are selecting the greatest. We got 1,245 is the greatest. Okay, so then we write our answer out. The greatest is $1,245. And the way we're going to get that is by 9, and my x value was office visits, and 6 surgeries. Okay, so that would be my answer. Make sure you're writing it out. $1,245 for the day by doing 9 office visits and 6 surgeries. Okay, so that is example 1. If you have any questions, probably write them down, or if you're in class, please come and see me. Otherwise, we're going to move on and look at example 2. Example 2, you need to buy some filing cabinets. You know that cabinet X costs $10 per unit. I'm going to write this down. It receives 6 square feet of floor. It requires 6 square feet of floor space and holds 8 cubic feet of files. Then we got cabinet Y. It costs $20 a unit, requires 8 square feet of floor space, and holds 12 feet of files, excuse me. You have been given $140 for this purchase. Though you don't have to spend that much, the office has room for no more than 72 square feet of cabinets. How many of which model should you buy in order to maximize storage volume? Okay. So this one we're maximizing volume. So since I'm maximizing volume, my numbers that pertain to volume, I'm probably not going to use any of them until I get to my step 5. Okay. But everything else I'm going to use to write an equation. I also look at the equation or the question. It says how many of which model should you buy? So what models are we talking about? Well, we're talking about the number of cabinet X and Y is going to be the number of cabinet Y. If I'm going to write my equations, okay, lots of labels, but I would say, is there some labels that I could go ahead and kind of piece together? I see $10 for X, 20 for Y, and is there a total money? Yeah, there is. So let's put all the money together. Got a money equation. So we have 10X plus 20Y, and you have been given $140. So should this be bigger than 140 or smaller than 140? I don't have more than 140 to spend, so it's got to be smaller than or equal to 140. Then the next thing, so I've used my money. Now I move on, I say 6 square feet of floor space for cabinet X, 8 square feet. Do I have total square feet? Yes, I do. Got a little erased here on mine. We need 72 square feet. So let's put all of those labels together. So we will have 6 square feet for each cabinet X plus 8 square feet for cabinet Y, and it can be no more than 72. So it needs to be smaller than or equal to 72. And then I have my volume, which is their cubic. Remember, volume is feet cubed, so my cubic feet. So that I'm going to use those labels later. Then I just go ahead and put my, I call them kind of silly, but you got to do it. X is greater than or equal to 0, and Y is greater than or equal to 0. You're not going to have negative cubic feet. Okay. So there is step 2. Sometimes people put this little curly bracket to show that that's my system. That's my answer. Then step 3, we're going to go ahead and graph. Like I said before, best way to graph is through finding those intercepts. So I'm going to take the top one, 10x plus 20y, and it's going to equal 140. Okay, so I plug in 0 for x. Pretend that this is gone, because 10 times 0 is 0. Then I would take and divide both sides by 20 to get my y value. 140 divided by 20 is going to give me 7. Now I need to go ahead and find my y-intercept, so my x-intercept, so I let y be 0. Plug in 0 here, so that's gone. So if I'm solving for x and this is gone, we would divide both sides by 10. So 140 divided by 10 gives me 14. So using those 2 points, I'm going to go ahead and I am going to graph this top equation. Okay. Maybe before I get too carried away, I'm also going to label. This is my x is number of x cabinets. Oops, number of x cabinets. And then this is number of y. Then I'm going to graph. So I got 0, 7, and 14, 0. And like I said, please use a ruler if you can. Then we would shade. So the way we shade is checking 0, 0. If I plug in 0 for x and 0 for y, I have 0 on the left side. Is 0 less than or equal to 140? That is true, so I would shade towards 0, 0. Now I'm going to go ahead and graph my next equation. So I would have 6x plus 8y equals 72. So if x is 0, 6 times 0 is 0. So I have 8y equals 72. So 72 divided by 8 is 9. So I have 0, 9. Then I'm going to do the opposite. Need to find my x-intercept. So I let y equal 0. So I plug 0 in for y. This is gone. Then I would divide both sides by 6. 72 divided by 6 is 12. So now I would plot those 2 points to get my next line. So I have 0, 9 and 12, 0. Then I'm going to go ahead and connect them. And I'm going to look at where I'm shading for that one. If I plug in 0 and 0, that is less than or equal to 72, so I'm going to shade towards 0, 0 because that's true. Okay, so where am I going to be double shaded? I'm going to be in this little area, and once again, these 2 constraints are keeping me restricted to the positive answers, so I'm just going to graph here. You don't have to graph them, but just that's why, and I would make sure you put them in your system of equations. And now, step 4 is to find the coordinates of our feasible region. Okay, so I have, once again, there's 3 easy ones. Might have to do a little work to find that one. Let's write down our 3 easy ones, and then let's talk about finding this one. Something else I want to talk about is, so far, these 2 examples have had 4 coordinates, but it doesn't have to be 4. I actually could have had this little triangle shaded, okay? And then I would have only had this point, and this one. So there could be 3. So there could be less than 4 points, or there could be more. It just depends on the shape that you are given. So something to be aware of. But for 4, let's write them down. We got 0, 0, and then we would have 0, 7. The other one is 12, 0. And then the 4th one, we got to go ahead. Maybe your ruler shows it nicely. Mine doesn't look very nice, so I'm going to go ahead and we're going to solve it. It's where the 2 lines intersect. So my 2 lines are 10x plus 20y equals 140. And then I have 6x plus 8y equals 72. Now this one I can't do substitution on, so I could do elimination. I mean, you could do substitution if you wanted to solve and do it. It looks like since everything's nice and lined up, I would recommend elimination. So I'm going to do that, and I am going to eliminate my x's. So if I look at my x's, I would see that 10 and 6, I can multiply them both to be 30. So I'm going to take the top equation times 3. And I'm going to take the bottom equation times -5. and then I'm going to distribute, and I'm going to combine my like terms. So 10 times 3 is 30x. 3 times 20 is 60y equals 3 times 140, which is 420. And then I distribute my negative 5. So negative 5 times 6 is negative 30x. Negative 5 times 8 is negative 40y. And then negative 5 times 72 is negative 360. Then we go ahead and add. My x's cancel. This gives me 20y is equal to 420 minus 360, which gives me 60. If I divide both sides by 20, y is equal to 3. So it's saying 3 for my y, which is probably right. Looks like roughly around 3. And then to find x, we go ahead and plug it into one of the two originals. Doesn't matter. I'm going to do the bottom one, smaller numbers. So we would have 6x plus 8 times 3 equal to 72. 8 times 3 is 24. Subtract 24 from both sides. 72 minus 24 gives me 48. And if I divide both sides by 6, x is equal to 8. So this is the point 8, 3. So my feasible region, my fourth point is 8, 3. Then step 5 says write an equation to be maximized or minimized. We are maximizing. So how many of which model should we buy to maximize volume? Okay, so we're maximizing volume. When I think about volume, it's feet cubed, units cubed. So I have to find my units cubed for this one. So cabinet X takes up 8 cubic feet of file. So we would have 8x plus my file Y takes up 12 cubic feet, so 12y. So there's my function to be maxed or minimized. And like I said, 4 and 5 you could all put into step 6. So I make my table and write down my function to be maximized or minimized. This is also sometimes called your objective function. It's what your goal is you're trying to figure out. Then I write down my points. Got 0, 0, 0, 7, 12, 0, and 8, 3. And we plug them in. So we got 8 times 0, 8 times 0 plus 12 times 0, which gives us 0. We have 8 times 0 plus 12 times 7. If you type that one in, you should get 84. If you do 8 times 12 plus 12 times 0, we will get 96. And then lastly, we have 8 times 8 plus 12 times 3. So I got 64 plus 36, which gives us 100. Once again, we're maximizing for this problem, so we want the greatest answer. The greatest answer we have out is 100. Okay, so we want 8 of the x, which is we want 8 cabinet x units, or yeah, filing cabinets. And then we would want 3 cabinet y's. And what does the 100 represent? Well, that was our volume. So we would get the most storage, most volume of 100 cubic feet with buying 8 cabinet X and 3 cabinet Y. Okay. So that would be our max storage. Okay. So that is it for example 2. Like I said, lots of steps. You could eliminate and put just right away, go to step 6, and then write your step 4 and 5 right on the table. That might save you a little bit of time, a little bit of writing. But there is Unit 3 Video 4 for you. Now what you need to do is you need to go ahead and work on Unit 3 Practice 4, and if you have any questions, please come and see me. Otherwise, have a great day, and I'll see you later.